Good morning. Welcome to the September NTSA Central Florida Tech Grove Connect webinar. We're so pleased that you've joined us today, and especially welcome to those of you that have been with us before and decided to come join us again for yet another very interesting topic that is featuring a team that is one of the best papers or best tutorial teams from the 2021 ITSEC. This series of webinars that we do in partnership with NTSA each year is to highlight the stories and the people behind these best papers and tutorials, and to enable you to be aware of them and to learn more about opportunities to engage with them, and probably meet them at this year's ITSEC, because I think pretty much all of the teams we feature will be at the 2022 ITSEC as well. I'm Carol Ann Logue. I am the director of the Central Florida Tech Grove, located in Orlando, Florida, in the heart of the U.S. military simulation, modeling, and training community, government, industry, academia, all working together for rapid innovation, innovative solutions for our men and women in the service and training and simulation. I want to take just a few minutes to tell you very quickly about what Tech Grove is and what we do and focus on, and would love to have opportunities to talk to you further about ways to connect with us. We have been open for a little over a year and a half. January of 2021, we opened our doors, and we represent a truly innovative partnership within the federal government and particularly within the national security sector, in that we are an innovation hub specifically for modeling, simulation, and training and human performance. But what really is distinct about us is that we are multi-service, multi-agency funded. We were created through a partnership intermediary agreement between the Naval Air Warfare Center Training Systems Division here in Orlando and the University of Central Florida Research Foundation, which is a nonprofit. But from day one, we were also equally funded by the U.S. Army's PEO STRIVE, Air Force Agency for Modeling Simulation, and the U.S. Marine Corps' Program Management Office for Training and Simulation. In the last year, Army Futures Command Synthetic Training Environment, as well as the Army's Simulation Training and Technology Center, has also come in as a member of Tech Grove. And we have another service soon to be joining us, and other agencies that are in conversations with us because of this collaborative opportunity to engage with each other across the defense spectrum and work together for solutions. This is what we focus on. This is what our customers focus on. All these areas of enabling technology and innovation that support innovative, cutting-edge modeling, simulation, and training and human performance products. And hopefully all of you see yourself somewhere in one of those phrases or words or areas of capability and technology on there. And if you do, we'd really love to know what you're doing so that we can engage you in our community. We have 3 missions at Tech Grove. That is to grow the defense industrial base, bring companies, academics into this industry that aren't currently doing business, and support those that are early in supporting this sector. Tech transfer, engaging with our customers in licensing opportunities, CRADA opportunities, joint research and development opportunities, and finding solutions for problems that they have. And that in particular may be an area where you can share with us your capabilities and solutions, and we can help align them with the needs and the problems and the gaps that our customers are sharing with us and asking us to find new innovative solutions for. There's lots of ways to engage with us. We have a very robust, an increasingly robust calendar of activities, many of which we do on a regular basis, monthly, quarterly, semi-annually, or annually. We have, in addition to this Tech Grove Connect webinar, we have others coming up soon. Our October webinar, we're going to be featuring some of the teams, the gamers, game development teams, as well as the government customers behind the problem statements they worked on that participated in our recent and annual Armed Forces Jam. And in that jam, we had problem statements from the Navy, Army, Air Force, Space Force, and the DoD CIO office for electromagnetic spectrum, because they're looking significantly at gamification for training in that sector. So we had a wonderfully diverse set of problem statements, and we hope you'll join us for that to hear all about it. And we're very excited to announce the next date for our second and next Tech Probe Mixology. This is a series we've started asking just a simple question related to the metaverse, and then handing it over in almost a fireside chat atmosphere to the CTOs of several of our Tech Grove government members, as well as an industry representative and an academic representative, to dialogue and have some interesting conversation with you about this question. What are the human implications of the metaverse? Lots of ways to connect with us. I hope you will. But now let's move on to the main event, which is our team here, Kevin and Arena, who are both from the University of Buffalo and presented this fascinating tutorial at ITSEC 2021 around advanced air mobility of flying cars. What is this all about? I just know I want one. Traffic on I-4, Kevin, just gets worse. So when am I going to get one? That's my question. So I'm going to turn it over to the two of you. The last thing I'll say is, for those of you that took the time to submit questions ahead of time when you registered, thank you so much. Kevin and Arena took the time to look at those questions, provide some initial answers, and I will be dropping those into the chat at the appropriate time in their presentation when they're actually going to be talking about what you ask about. But in the meantime, those of you on the line, put your Q&A in the Q&A on the platform here, and we'll all be watching to make sure that we address your questions in the time allotted. With that, Kevin, it's all yours.
Thank you so much, Carol Ann. Thank you, Tech Grove. Thank you, NTSA, for this opportunity, for this forum. We're very grateful to be here today. It was nice for me for us to receive this invitation, because it's an opportunity to revisit this subject matter that's so near and dear to us. As Carol Ann mentioned, we presented this tutorial at ITSEC last November. It seemed to be well received, well attended, and like I said, we're excited to talk about it again. These areas of advanced air mobility, flying cars, and how we can use modeling and simulation to potentially revolutionize the transportation network of tomorrow. Quick shout out to our entire team, many of whom couldn't be here today, but one of whom very gratefully joined me, and we'll talk more about her momentarily. But Panos, Steve Still, Rachel Shafriar, and Gregorios from Edinburgh Napier, and of course, Dr. Arena Benedict is here to join me here today for this dialogue. So by way of a very quick introduction, my name's Kevin Hume. I'm a senior program manager at our Transportation Institute here at the University of Buffalo, which is called the Institute for Sustainable Transportation and Logistics. Our benefactor is a guy named Stephen Still, who has enabled some great opportunities for us here at the university, and is a co-author on this tutorial. Couldn't be here with us today, but he's a great guy, and I'll be mentioning him at various points throughout today. But Dr. Benedict, maybe you could say a few words about yourself as well.
Hello, my name is Irina Benedict, and I'm assistant professor at UB. I'm actually very happy to be in this team, because this topic really great, and I also want to know when I finally can get a flying cars. And it's not a question in the air. We actually looking into acquiring one for the department for research purpose. So my area of expertise is mostly intermodal transportation, and I'm interested to study how all this advanced air technology mobility can be used to improve our supply chain at different aspects. It's mostly last and first mile. This is where we see AM to be more useful, but long haul is also a question, maybe long to go future, but still we are exploring that as well.
Great, thank you. It's great to have you here. As Carol Ann mentioned, we're going to be answering questions as we go. Various of you took the time to pre-submit questions, and we tried to take the time to pre-answer those questions and interject them at appropriate places throughout this slideshow. So we'll get to those. And if any of you have questions in real time, we'll do our best in this hour to get to your needs as well. Old habits die hard. Whenever you create a tutorial at ITSEC, we start with learning objectives. So for this webinar, I'm going to do the exact same thing. We hope that in the next 40, 50 minutes or so, we can identify what's the current state of art with these so-called flying car technologies. We will summarize some of the key transportation challenges that mandate societal change and evolution. And this is kind of what Dr. Benedict just talked about with this whole notion of intermodal transportation, looking not just at driving, at flying, but kind of the whole system as it works together. Carol Ann mentioned LVC up top. I'm sure many of you know what this taxonomy means and stands for, but we'll talk about that a little bit today, how we can apply LVC fundamentals to try to enable the potential sustainability of flying car technologies. We can then analyze current development efforts to assess both technological and human factors impacts, which will finally allow us to evaluate collaborative prospects, we hope, to leverage modeling and simulation in this highly emergent and bleeding edge domain of interest. And I guess I would say number 5 is the big one here. We're very early in these technologies now, and it's important to get this dialogue started earlier than later. And this is why I think this Tech Grove discussion, this seminar, this webinar today is so important and so potentially valuable. Okay, so origins. This slide here is by request of Carol Ann. She asked me to talk very briefly about, well, how did this project come to be? And I think the answer to that question has 2 aspects. One that's quite simple and obvious, and one that's a little bit more anecdotal. The simple and obvious one is Dr. Benedict and I and a variety of other staff, students, and faculty here at the university, many of whom are co-authors on this tutorial. This is our business. We work or are affiliated with transportation engineering, the SSI-STL Institute that I mentioned earlier, and this is what we do. We look for new and novel mechanisms for sustainable transportation. Dr. Benedict mentioned the supply chain, logistics. These are all concerns that we look at in our research and in our current and future modes of training and education. The second answer is a little bit more detailed and anecdotal. Dr. Anastopoulos, who's one of the co-authors on this tutorial and a close colleague of both of ours, and I were having a chat a few years ago, 4 or 5 years ago. At the time, he was trying to bring me on his team, and we were having a dialogue. And he asked me, "Hey, Kevin, you know, what's interesting to you in research? What gets you excited?" And I shared with him a lot of ITSEC related things, modeling, simulation, entertainment, thrill rides. You know, a lot of this is our career passions of mine. And so I extended the courtesy back to him and I said, "Hey, Panos, you know, what fires you up? What excites you?" And he said, "Hey, Kevin, you know, flying cars has been a lifelong career passion of mine." And when he said this to me, I honestly didn't know if he was being serious or joking. I didn't know in my ignorance. And this is only 4 or 5 years ago. So I made it my mission after that discussion to educate myself and to learn more about what's out there. And what I quickly found out was that this is admittedly an immature field, but it's far more mature than I ever imagined at the time going into that discussion. And really that dialogue that we had 4 or 5 years ago now was the primary impetus for us creating this tutorial. And by extension, the primary impetus for us being with you on this webinar today. So I hope with that background, we can proceed and talk a little bit more about how flying cars are beyond the Jetsons, as you see on this slide, and beyond science fiction and Blade Runner, as you see on this slide, and really coming into real world happenings. So the first thing I think we should talk about is nomenclature. NASA recently has coined this terminology that's maybe a more formal definition for this notion of flying cars, which lies in the back of our mind in more kind of science fiction context. But advanced air mobility is kind of the accepted terminology that's used now. and as NASA defined as the safe development of an air transportation system that can move both people and cargo. For example, small package delivery drones. You're hearing a lot about how, for example, Amazon is trying to find ways to deliver packages right to our doorsteps using drones or experimental aircraft. Passenger carrying air taxis, we're going to get to that shortly, the rideshare industry. Between locations often underserved by aviation, and that's a critical point, that it not just be kind of, wealthy urban and suburban areas, but also more ruralized areas that are often underserved by conventional aircraft. And these are revolutionary, they're experimental, they're very new forms of aircraft that potentially combine ideal characteristics of both planes and cars, so that we can not necessarily be constrained by the 2D workspace, the XY workspace that we have on the ground that's often encumbered by topography, poor weather, construction, traffic jams. We all know from our daily commutes how it can be challenging on the ground. And if moving to the 3D airspace can kind of alleviate some of these challenges, it's something that we need to look into. And like I hinted at earlier, this notion of flying cars from cartoons, from science fiction, if you will, falls within the general domain of this more formalized AAM concept. But this transportation network of tomorrow seems nearer to science fiction than science fact. And as my little anecdote mentioned earlier, that was my line of thinking just a few years ago. Yet technologists, stakeholders, subject matter experts in this domain are predicting that these so-called flying cars could be available for commercial use by as soon as 2025, which is just 3 years from now. Now, I tend to be a little bit pessimistic by nature. Anyone who knows me will affirm that. I still think that's a little bit optimistic, but I think we're within the ballpark that within the next decade we might start to see some of these technologies emerge. But a great topic relevance to modeling and simulation. I assume today all of you on Zoom, many practitioners from this field, and certainly LVC models and simulations, live, virtual, constructive, will be necessary to advise future deployment of flying cars. And we'll be saying a little bit more about that with some detail later in this slide deck. Many downstream impacts that are of relevance to ITSEC. Again, I'm sure there are many annual attendees at this great symposium that's coming up in just a few short months. The 3 pillars of ITSEC: training, simulation, education, policies, which we'll talk about with some specificity in just a few slides, human performance analysis engineering, and of course, being a bleeding edge technology, ESIT, innovative technologies, emerging concepts, certainly is relevant as well. Okay, so quick note about rideshare, and then a quick reminder that I think we have a few questions that we're going to address on this slide once I get to the end of it. But if we think ahead to some of the private sector industry who could benefit from advanced air mobility, these so-called flying cars, I think we don't have to stretch our minds too far to know that rideshare is a huge potential early adopter of these technologies. In fact, they're already doing it. Uber, Lyft, and other companies are forecasting these so-called VTOL, vertical takeoff and landing vehicles, that are easier to fly than helicopters and likely in a dedicated or so-called segregated airspace. On-demand aviation has a great potential to improve urban mobility, reduce time for daily commutes, going to and from the airport, for example, C market travel to B market travel, B market travel to A market travel, and so on. For any of you interested, I'm just touching the tip of the iceberg today, but Uber has created this strategic vision that they call Elevate. So please look online, look on Google. They've got a PDF out there. They've got YouTube 3D renderings that show what a commute might look like in a flying car, bringing together engineers, investors, scientists, policymakers to realize this incredible future strategic vision, where they've already invested millions in these technologies. So Dr. Benedict, I think we've got a couple of questions on this slide. Could you remind us what they are, and feel free to tackle them if you'd like.
Yeah, there are two questions on this slide. One about logistics, how all these private vehicles can be incorporated into our existing transportation, and especially in local regions, how all this decision will be made. And another one about electrification. So to be honest, I haven't understood exactly a question about electrification. I have posted long answers in answer chat in Q&A. So for the first one, we have seen, a lot of different research directions in the literature and on conferences. And so far, the only consensus that I have seen related to AAM and its deployment in the future, that it can bring a lot of advantages, and it is a big challenge. Literally, this is the only consensus that I have seen. And this is mostly, in my opinion, comes from the fact that we don't know the final choice of vehicles that will be in the air. Maybe it will be not too many different types of the vehicles. Will it be a vertical takeoff and landing, or they will require runway? So all of that brings completely different issues, and solutions will be different. That's why in the literature, all of them right now are discussed and explored. So there are no good answer here. I also posted some information that I think will be tackled in the first line of challenges. For urban transportation, it will be obviously safety. Safety always it's the first one, but also noise. Air transportation probably it's assumed to bring more noise while they're operating. So solving this issue is imperative to actually have this type of transportation available. Without solving it, it's not possible to have it in urban settings. So for electrification, let me know if I haven't answered the question correctly. So the question was, how has electrification of flying cars, power plants figured into the concept and planning of this potential means of transportation? So if you're asking about electrifications of flying fleet and choices that we should make, my personal opinion, we have to make pro-electric vehicle choice, and it should be bring as high as our social value. Like we have safety as a value. So electrification of the fleet should be the value. And we have seen it adopted in this way in Europe. And also China is doing a lot on this front. And actually last year they manufactured and sold more electric vehicles, or road electric vehicles, not flying vehicles, than all other countries together. So if this will work out, so we do have 2 test beds to see how it actually will work. And we will have a lot of information for our policymakers to make a decision. But IMCHA, again, it's my opinion, it's not an engineering solution and decision, it is a political decision.
Great, thank you, Dr. Benedict. I'll just quickly piggyback on some of the things she said. On this slide, I put my opinion that I think, at least in the short term during initial deployment, you're going to have a segregated airspace for these types of vehicles. Integration maybe with commercial and military aircraft in the much longer term. I think in the short term, segregated airspace is probably what we're going to see. The other thing I'll quickly mention is Uber's beautiful rendering here on this slide, which I apologize, it's not that large, but what you see there is what I think is being termed a vertiport. And these types of facilities, I think, are going to serve triple purpose. Number one, takeoff and landing sites. Number two, parking for vehicles, for people coming to and from these centralized vertiports. But number three, also a location to charge your vehicles that will require, a centralized powering station. So just piggybacking on Dr. Benedict's much more technical answers. I don't know about all of you, but I love these Gartner hype cycles because it's a great way to look at a new leading edge, bleeding edge technology in the context of other technologies that are also in development. And it seems like many new technologies, most new technologies kind of follow this same and unfortunate general trend. You have an early innovation trigger, and there's lots of excitement and publications and news articles and early grants, and then quickly you reach that sort of peak of inflated expectations where you look back on the technology and say, wow, it's not up to what we thought it was going to be. And then you go to the bar with your friends and you reach your trial of disillusionment. You have a few beers and you say, wow, that was maybe a good idea. But then you sort of have this slope of enlightenment again, where you say, well, all right, it didn't work the way we thought it was going to work, but it can still be a functional thing. And then you can actually reach your plateau of true productivity. Many technologies, it seems, work out this way. From my own experience, virtual reality, when I entered the workforce in the late 90s, this is how it went. It was the next big thing until it wasn't the next big thing. But then, Oculus came along and kind of re-revolutionized things, and now we're actually making progress with VR and AR and all these technologies that Carol Ann mentioned as part of the Tech Grove initiative up front. So too is the case we would expect with flying cars. And this is a recent Gartner hype cycle on automated technologies, and you can see flying autonomous vehicles is prime on the innovation trigger right now. And what we want to try to do is reduce that peak of inflated expectations, make it a little bunny hop as opposed to, a big plateau. And one of the things that I think we can do is learn from, the successes and the failures that we're going through right now with autonomous ground vehicles. We've all heard how, cars are going to be automated. Google cars are driving all over the planet now, and it's 3 years away, 5 years away. And I've been hearing that it's 3 or 5 years away for 20 years now. And I think it's because it's a challenging, complex, interdisciplinary problem where it's difficult to forecast all these challenges when there are an infinity of challenges. So again, a great reason for this webinar today is to get stakeholders together, get the conversations moving early in this process of figuring out how this is going to work, and hopefully, again, we can reduce that peak of inflated expectations. Slide 8, I think we have another question or two at the end. So Dr. Benedict, if you'd remind me when we get there, but a very quick shout out to, and a quick sales pitch. I promise there won't be many, but a couple of years ago in 2019, our team published a paper at ITSEC where we looked at some of the early notional policy standards management acquisition issues for their PSMA subcommittee on flying cars. We think we were the first or one of the first to publish at this forum in this domain, and it was an extremely exciting opportunity for us to kind of, wave our hands over some of what we think are the primary policy issues that are going to be related to the rolling these technologies out. As Dr. Benedict mentioned earlier, safety is always at the top of that list and a primary driver for the technological viability of any new technologies. Sustainability is a big issue that we're always thinking about. Legal standards, economies of scale, logistics. Dr. Benedict again mentioned earlier that when we think about new modes of transportation, it's not always just human beings and people, but goods and services. We've seen during the COVID pandemic how the supply chain has been stretched to its maximum, where it's kind of screaming new and outside the box modalities for transporting people and goods. Environment, we have to think about the future and saving our planet and these so-called green concerns, if you happen to believe in them, which I do and we do. Energy, emissions, life cycle, noise, is going to be a big issue if we've got a lot more so-called flying vehicles, tooling about in the sky. Navigation, VTOL standards, vertiport designs and layouts, which we, hinted at earlier when we mentioned the Elevate initiative. And of course, cybersecurity. Whenever you're dealing with computers and subsystems that deal with computation, we have to forecast and regulate cyber crimes. It's unfortunately a huge issue, always a huge matter at ITSEC, both in tutorials and the papers track, and of course in the private sector and government as well. But if any of you wish to see more details on some of these issues, we do have a paper that was published, 19140. You can check the ITSEC paper repository for a few more details. But Dr. Benedict, I think we had a question or two at this juncture.
Yeah, the question was about safety, how we see autonomous flying cars will deal with hard weather, especially thunderstorms and turbulence. That was the question. So in general, that's a question that we are not expert on. We are working with the car manufacturers as well as with our mechanical engineering and aerospace engineering partners at university. So they usually bring those insights. Nevertheless, one comment here from us at our facility, we do have at our university, we do have a facility to test drones. It is called SOAR, Structure for Outdoor Autonomy Research. So it is outdoor facility, so not all types of scenarios can be simulated there. Nevertheless, because it is enclosed, so we actually have a freedom to experiment there whatever we want. So it makes it convenient for such weather-related research, assuming weather condition. And it is in Buffalo area, so snow, weather, some wind as well, available at your service, and rain as well. Yeah. There is another question. Have you engaged with the FAA Next Gen initiative in any of your work with AAM, Kevin? Have you worked with an FAA Next Gen initiative?
No, I'm not. I'm just seeing that question right now. Not familiar with that. I apologize.
So I put that question in there because I actually just visited last week one of the 3 FAA Next Gen facilities in the country, and it happens to be in Daytona, Florida, in the same building with our UCF incubator up there, and I visited with them to get an update on the work they're doing, and I'd love to connect you with them because I think there's a lot of alignment in the issues you're looking at and what they're looking at in terms of how they're modeling and simulating the next generation of commercial air traffic and all kinds of fascinating things they're working on there. So I'll follow up with you on that.
We'd appreciate that. Thank you very much. My opinion on this matter is that it's going to be an issue. You know, you think about maybe the near-term usage in a rideshare context, maybe getting on a flying car, so-called flying car, going from, you know, let's say JFK Airport to downtown Manhattan. It's probably going to be a lower altitude flight, lots of turbulence near the ground during certain weather. You know, also thinking in the near term, 100 years from now, maybe these vehicles will be fully autonomous. But in the near term, you're going to have pilots overseeing the operation of these vehicles. And if you've got lots more aircraft, lots more pilots in the sky, it's going to demand experience. It's going to demand training, especially in these types of situations, thunderstorms, low light, fog, you know, where you often see with smaller aircraft, you know, when there's untoward events, usually visibility factors into that. So it's definitely a challenge. It boils down to and comes back to safety, and it is going to be one of the things that's going to need to be overcome. So whoever asked that question, thank you. It's very insightful. Speaking of training, it's good timing. So we're thinking ahead to all the different types of training issues that might result should this paradigm actually take off, pun intended. And I just mentioned the first one of them, operation, pilot certification. You're going to need skilled licensure to potentially both drive and fly a vehicle that has these hybrid capabilities, you know, especially if we have many more pilots in the sky. This is going to be a huge issue with these so-called experimental aircraft. type certification, pilot approval for diverse experimental vehicle types. I don't remember if I'm going to mention it later, so I'll do it before I forget. At ITSEC in 2021, when I presented this tutorial, someone from the military was there who informed me that there's upwards of 300 entrepreneurial efforts in this so-called flying car space. I would have guessed maybe 50. It boggled my mind to learn that there were 300. So that is to say, potentially 300 different experimental vehicle types that we could see over the next 5, 10, 20 years. So lots of different specialized type certification and pilot training that will be required. But the big one that we shall not forget is maintenance. You know, all of us with our own vehicles now, I can put air in my tires. I can change the oil. I can fill the windshield wiper reservoir and do basic maintenance on a vehicle. But thinking ahead with many more complex systems, moving parts, computers, computer systems, computer subsystems, many potential moving parts, points of failure, maintenance is going to be a huge and likely expensive and likely highly specialized sector where it's going to demand specialized training. So training's always the most emphasized thing that we hear about at ITSEC every year. This year, no exception. And these are just 3 areas that are going to be impacted by this emerging area of interest. Okay, LVC, I mentioned it earlier. I'm sure most of you on this Zoom call are familiar with what this taxonomy is. It stands for Live Virtual Constructive. Carol Ann mentioned it earlier, also as a priority with TechGrove, certainly no exception in the AAM space. Will be essential for research, simulation, training, and for flying car testing, experimentation, and validation. I don't mean to take up valuable time, but for those of you who are unfamiliar, live is a simulation involving real people operating real systems. Virtual is a simulation involving real people operating simulated systems. And constructive is simulated people operating simulated systems. So I think if you just use a little bit of common sense, you can see how this paradigm is going to be immediately useful for near-term and future flying car testing. In the live domain, we need to deploy physical enclosures to encapsulate and constrain the testing region when we do testing, likely in the near term at partial scale first. We can't just design a full scale, full vehicle prototype, turn on the ignition and then go flying in the sky. Millions of hours of testing are required first, and we probably want to leverage drones and quadcopters to do this at scale initially, to answer all the questions that we haven't thought of yet, to enable us to prototype and pre-visualize conceptual urban planning and design. Where are vertiports laid out, cityscapes, takeoff and landing zones in rural, suburban, and urban settings. Many, many questions to be answered, and the live testing domain is, as we all know, invaluable. Dr. Benedict mentioned earlier, again, a quick bit of shameless self-promotion. We're so fortunate here at the University of Buffalo to have a drone testing enclosure. It's called SOAR, Structure for Outdoor Autonomy Research, SAOR. It's not the only in the country. It's one of few and one of the bigger such facilities. You can see there on the lower left. It's a wonderful facility for us to do some outdoor testing. And again, as Dr. Benedict mentioned, we in Buffalo are so lucky, to have terrible weather 10 months out of the year. So it enables us to do testing in these kind of poor weather conditions that we know are going to be an issue as AAM continues to emerge. Okay, slide 12. I think we have a question that I'll remind Dr. Benedict about when I get to the end of this. But virtual is definitely my domain of interest, my primary domain of interest. We know we're going to be dealing with excursions that are both airborne and ground, and likely both partially manual and autonomous at different parts of the transport regime. Looking at transition zones, takeoffs, landings will be most critical during preliminary deployment of these technologies. So virtual simulation will enable the critical assessment of tolerance for the human machine interface. How will we interact with these new vehicles? We're so used to driving our cars now with the 10 mile per hour per 10-foot rule. As you're driving, you've got to leave that space cushion. But in a future regime, maybe this won't be a necessary mandate, but it's going to be a transition where we have to learn these types of things, for which we're already looking ahead. And we've developed this, we're developing using the Unreal game engine, this so-called virtual campus for hybrid simulation in development, but we're looking at, putting together game engine based test tracks, runways, these sort of hybrid environments for both driving and flight, where we can hop in a simulator with motion and visual and sound capabilities in high fidelity and answer some of these key questions. Dr. Benedict, I think there was a question.
Yes, there is a question, one question here, but before that, there were a question, couple slides before that we just received. So maybe you have, I answered, but maybe you have some opinion as well. Will segmented airspace be enough, or do you anticipate it having to be regulated? And if so, if this is a role for FAA air traffic controllers, private, or a requirement for airspace to have artificial intelligence that allows for airspace regulation automatically. So it's, in my opinion, it will be guessing at this point, because we don't know technology extent and how mature and how, again, safety and noise, when it will be solved, then we can talk more precisely and give a better prediction of that. But if you want me to guess right now at this point, so I would say airspace, air traffic controllers has nothing to do with that. They are not suited for that. It shouldn't be done in the way how we regulate air traffic. It should be a technology solution for sure, just because of the scale, how many different aircraft will be in the air. And connectivity is a technology here. Will it be regulated by artificial intelligence or not? Well, probably it will be some components of that, but again, first solution, first technology that should be used, connectivity, of course, obviously, to make AI working with that. So that's my 5 cents on that.
Yeah, this is a great question, great responses, Dr. Benedict, and I do think there will have to be some kind of regulations, whether it's FAA or another entity. Like Dr. Benedict said, it's sort of a guessing game at this point, and that will be something that will need to be determined in the near term as these technologies evolve. But I don't think what we can have is a free-for-all in the sky. And that really kind of bridges into the next topic we're going to talk about, which is constructive. So maybe I'll use that as a unplanned segue to the next slide. But I think there's going to need to be order in the sky. Maybe initially it's only flying police cars and flying ambulances and flying construction vehicles, where we don't have to worry about it so much because it's, important entities flying, emergency entities flying through the sky. But assuming these take off, 50, 100 years from now, when our great grandkids have their own flying car to go to and from school, there's going to have to be some order there. So this is where I think constructive is in many ways the most important part of the LVC taxonomy, if we're going to handle them separately, which of course we never do. But what we're trying to do, and we do have some specialists here at the University of Buffalo looking into this, is embracing game engine technologies to determine flying car flight network interoperation. And I see parallels between this challenge and what we're trying to do right now and what the military has done for a long time with SAF, semi-automated forces, in a slightly different context. But as I hinted earlier, the game here is to try to translate 2D ground traffic models to try to effectively better utilize that third dimension of travel going vertical. I was just went on a road trip last week through Boston and through New York City. And as we all know, places nobody wants to drive. Whether you live there, whether you're a tourist, it's always a challenge. And if we can find ways even to take 10% of the traffic that's on the ground now and effectively and safely, bring it into that third dimension, it's going to be a huge win, especially as our infrastructure continues to devolve. So trying to find ways to maximize cooperative flow within travel tiers, grids, whatever height tiers, whatever they're eventually called, while guaranteeing safety. What I see here is a massive multidisciplinary optimization problem. And it's firmly rooted in the constructive domain. So it's a challenge that we're already thinking about, already looking into. Some of our colleagues here at the university and from other schools, we're trying to frontline this challenge as we proceed. Now, this slide is very near and dear to me because as we were preparing this tutorial back in 2020, it fell during the pandemic. And, I was putting this together with help from our team, a tutorial on flying cars, and I was having doubts. We're going to get laughed out of the room. This is crazy. Hume, what are you doing here? Flying cars? Are you out of your mind? And then in July of that year, I was in my office, sequestered as we all were during that time, and I received a magazine from National Defense. The NDIA sponsored National Defense magazine, and on the cover of that magazine, Air Force aims to turn science fiction into science fact. Flying cars. So it was an immediate sigh of relief. The military's doing this, immediately adds credibility to what we're trying to do at the academic level. But that article was excellent. It came at a great time. It was knowledgeable for me to learn a little bit more about USAF's Agility Prime initiative. So please look that up for any of you out there. In the interest of time, we don't have a lot of time to talk about it today, but I think that article is still available online. But they talked about, at a notional level, takeoff capabilities, VTOL, going vertical then flying forward in the XY space like an airplane, helicopter initially like an airplane at altitude, manned, remote, and or autonomous operational capabilities. Obviously, the idea in line with sustainability is reduce life cycle costs. Many challenges, safety was the one that was emphasized in that article. Privacy, cybersecurity, again, not surprising, that will need to be addressed because, especially at these early stages, near to that innovation trigger, without public acceptance, any bad press is not very good, and commercialization and long-term adoptance of these technologies will not be possible. So it was just reaffirming for us to know that we're on the right track. We're doing the types of things military is doing, and hopefully for us that means some strong partnerships in the future. Dr. Benedict, I think there may have been a question or two at this juncture.
Oh, I think you actually answered the question. The question was, what are the air and road eVTOL platforms that DoD is currently engaged with?
Okay, so I think we did a good job of forecasting your question, or whoever asked that question did a great job of forecasting what we might be talking about today. So I hope that answered your question, but if it didn't, please check out Agility Prime and learn more about the great things USAF is doing right now. Manufacturer status, I mentioned earlier, over 300 players in the game right now. I think at ITSEC last year, we talked about maybe 10 or 12 of them. So today, in the interest of time, I'm only going to mention two. For any of you interested, spend an hour, do a Google search, and you will be amazed at the diversity of technologies that are in various stages of development right now. On this slide are two of the longer term groups. Terrafuja's TFX VTOL model, shown on the top right there, requires a big diameter for clearing of these quads on the side of the vehicle. It's hybrid electric, 4-passenger, operates on unleaded fuel that will power the electric motor pods. Longer range for a so-called flying car of up to 500 miles. And they're doing this design in cooperation with Volvo. So you're seeing a lot of the big names emerging. PALV is a company from the Netherlands that we have had very preliminary, somewhat collaborative discussions with. And theirs is an STOL vehicle, which stands for short takeoff and landing. So this is a true flying car in that it both drives, and flies in various modes of operation. It's a dual engine vehicle, 100, 200 horsepower with unleaded fuel, only 2-passenger, moderate range of 250 miles, 7 gallons per hour. So they're already thinking ahead to fuel economy, trying to be green, trying to, maximize resources and so forth. I'm only scratching the tip of the iceberg here, but I think, Dr. Benedict, another question on this slide?
I want to add a little bit on Palvi. If
Sure.
you are interested, Palvi, I checked today, prices hasn't changed. For a standard version, 400 Ks plus taxes, and for a full version, all features included, 600 Ks. And they're promising only up to 100 vehicles to be delivered to US. So if you're interested, you should be, in the hurry for those. So we do have a question. Will there be a standard altitude for each sky road? So again, it is a guessing at this point, but you can think about road vehicles analogy. We do have lanes, and that's something similar. Nevertheless, with self-driving cars, there are a lot of technology tested already. Simulations has been done that illuminates lanes as well as traffic signals if all vehicles are self-driving. It is possible. It's increased capacity of the road, of current roads. It's safe enough to be implemented. So the question here: will flying cars be self-flying or not? If yes, then it will be a different story. And one of the goal for our lab is to develop 3D traffic simulator in partnership with Georgia Tech University, and both approaches are considered there. For human-driven vehicles, then we definitely need to separate the directions, altitudes for different purpose and different types of the vehicles. But if it is self-driving, self-flying vehicles, well, then we can use space more efficiently and safely, I would say.
Great, thank you, Dr. Benedict. I see that we're under 10 minutes until the hour. What I'm going to do is make sure we get through our slides in the next 7 or 8 minutes or so. For any of you out there who are willing to stay past noon, Dr. Benedict and I will hang out for as long as there are questions, but I do have 6 or so more slides, and I want to make sure we get through those for those of you who do have to exit at noon. I mentioned Steve Still earlier, great friend of both Irina and I, and a huge benefactor for our institute. We're eternally grateful for his generosity to the university. We invited him to come with us today. He's a career aviation guy. He couldn't join us, but he did send us a valuable article that's so timely. And just this month, United Airlines has ordered 200 Eve Air Mobility, an Embraer startup, eVTOL aircraft. And this comes hot on the heels of just a few months ago. United also just paid $10 million for a pre-delivery deposit for 100 additional eVTOLs developed by another startup company called Archer Aviation. So it's reaffirming again to see the big commercial aircraft that we all fly, going across the country. They're thinking ahead to getting people to and from rental car places, to and from, highly rural areas, to and from, C cities to B cities to A cities to, their major hubs and so on. Flying taxis designed to transport passengers again between city centers, airports, remote areas. It's exciting to see such a timely news article like this. A few people had questions on human factors, which I think this and the next slide will suitably address, because our team, and primarily the credit goes to Dr. Anastopoulos and Shahriar Ahmad, his student, his PhD student. By the way, anyone hiring, he's going to be in the job market soon, getting his PhD. He has studied flying cars for the last 3 years, the most knowledgeable guy I know. So extremely shameless self-promotion, but he's a great guy. Anyways, he deserves a quick shout out here, as well as his advisor, Dr. Anastopoulos, for doing some papers, some human factors case studies 5 or 6 years ago, before really this was on my radar or the radar of many people out in the news, looking at some of the things that I think technologists should be looking at, which is human factors, surveys, and potential use cases. How will these vehicles be used? For activities, durations, time of day. So just a quick sampling of some of the results that we found from some fairly large scale surveys that Dr. Anastopoulos rolled out. Activities, not surprisingly, entertainment, work commutes, and so on and so forth. Duration, from the survey results, I found this surprising. The survey respondents desired trips of longer duration. For me personally, it would be short commutes, going to and from work, to and from the airport, which for me would be, 15 miles or so. But the surveys that we rolled out showed slightly different results. Time of day, not surprising, more likely to use during daytime than nighttime. Oftentimes, as I said earlier, untoward events with small aircraft happens during low light conditions, poor weather, fog, rain, poor visibility, and that kind of thing. Rate expectations, looking ahead to rideshare adopt. It's probably the first private sector to adopt these technologies. How much are people willing to pay more per mile of travel for this convenience? It'd be great to go to your airport and then take a flying car to your hotel rather than wait for a car on the ground and all the surface construction, traffic, and so on. Not surprisingly, people are willing to pay current rates and even a little bit more, up to $1 more per mile of travel, even $3 more per mile of travel. But not surprisingly, the survey showed that as you get more per mile of travel, it's going to be a wealthier person's game, at least during the preliminary rollout. And we all know that it's going to be more expensive. The vehicles, as Dr. Benedict outlined earlier, current price points are upwards of $500,000. So it's going to be a convenience matter in the short term. Another great thing that happened last year, just in advance of our tutorial rollout, was this article that came out literally in November of last year, a few weeks before our tutorial was offered last year at ITSEC. Tourism, not surprisingly, not surprisingly, Orlando, the hotbed of simulators, thrill rides, all the stuff that I love and have loved since I was a little child. But you see tourism, Orlando, greater there than anywhere. And so this article came out, Lake Nona Vertiport Plan for 2025, first of its kind flying car tourism in the United States, all electric VTOL vehicles, 5-seaters, short to moderate flight range of just under 200 miles, but they included these great renderings that show you the parking lot, the vertiport, the terminal, and really showing you in 2 dimensions what it's all going to look like. I think the forecast of 3 years from now is ambitious, but let's see. We'll all be at ITSEC in a couple of years. Hopefully, we can afford a $3, $4, $5, $8, $1,000 hour excursion on a flying car and actually see this happen in our lifetimes. So quickly to summarize, we're just at the end of our hour. I've got just a couple of more slides. We think this AM could be a cog in the puzzle of the emerging transportation network of tomorrow. We know modeling and simulation will be necessary. We know the live virtual constructive taxonomy will be required for test evaluation and validation. And for all of us who are annual attendees at ITSEC, it's very exciting because we know there's going to be many downstream impacts on training, simulation, and education. For all of you attending ITSEC, it's going to be here before we know it in just 2 short months. Just a quick preview that our team will be present. We have submitted and are so grateful that our paper was accepted in the simulation subcommittee this year. It's called Human Mobility 2049. Shout out to Blade Runner for any of you out there. It's time to act. An aeronautical conceptualization for tomorrow's transportation. And this little image that we put on this slide is our kind of roadmap of where we've been at ITSEC, thinking through PSMA issues, ESIT issues, simulation this year, to future issues if we're so fortunate to be able to present our future work in human performance, in training, and of course in education. And I know there was at least one question that was offered that was educationally rooted, which I promise we will get to, but not before reaching our final slide, which is to say thank you. Thank you to Moog for all their support over the years. Thank you to Stephen Still and our Institute for all their support for enabling us to look at this forward-thinking future vision of tomorrow's transportation. Thank you to my co-author and colleague, Dr. Benedict, for attending today. Thank you to Tech Grove and NTSA for sponsoring this amazing webinar. I had a great time today. Most of all, and most importantly, thank you to everyone out there in Zoom for your precious time. I know how valuable time is. We're grateful for you giving us your hour today for what I hope was a very interesting, engaging, and insightful talk. Carol Ann, I'm going to turn it briefly over to you.
So Kevin, I have a question, one more question for you. I told you I was going to ask you this for our guests that are here with us today. What do you need? How can they help and engage with you?
Yeah, thank you, Carol Ann. Should I be brutally honest?
Yes.
Say
yes.
What we need is, I won't say money, because everyone knew I was going to say that. I'll say sponsorship. You know, we've been writing grants for a number of years now to various organizations. I think, for example, an entity like NSF, the National Science Foundation, looks at our idea and loves it, you know, because they want the next thing. They want to fund the next big thing. But I think NSF even looks at this and says, wow, that's bleeding edge, and that's a little bit too bleeding edge for us. So we're going to keep cranking away. We're going to keep putting out these ideas, these papers. We're going to keep doing pilot studies, collecting data, trying to learn more, trying to inform the community. But what we're looking for, Carol Ann, is partnerships.
Partnerships, collaborate.
There's lots of things that we can do here. You know, we're good at the soft sciences. We're good at LVC and simulation, automation, virtual testing, human factors. But as Dr. Benedict alluded to earlier, there's things that we're not good at. You know, we don't develop the hardware. We don't develop the aircraft. So what I hope will come from our participation at ITSEC and from great webinars like this is just keep the dialogue going. And I think forming teams, interdisciplinary teams across academia, industry, government, is only going to strengthen matters for all of us and help us solve these problems and challenges more quickly. So thank you for asking that question. That I think is the most important thing that we wanted to say today through this forum.
Well, thank you, Kevin and Irina, for joining us today. I know I've learned a lot. It's interesting how this webinar and engaging with you and planning for it and reading your work is tied together some threads of things that I've been seeing and exposed to anyway over recent years. So I look forward to following up with you on a few things. Thank you all for staying with us for the hour and even a few additional minutes. I hope that you will join us on October 27th for our last Tech Grove Connect webinar this year, which will feature, as I mentioned earlier, some of the teams from our Armed Forces Jam, some of the government sponsors, and some fascinating insight into how DoD is pursuing use of gamification and partnering with commercial gaming industry to address and evolve and reimagine some of the simulation and training needs for our military. So look for that information coming to you from NTSA, and you can always follow Tech Grove on our LinkedIn, our Facebook, our Twitter page, and our website. Thank you all. Thank you, NTSA.
Thank you.
Thank you.